Hi everyone, so in this video I'm going to be going over another momentum question. This one involves momentum in 2 dimension. So let's go ahead and read the question. It says, Roger is making extra money by delivering newspapers on his bike so he can buy more wigs. As he's riding along going north at 1.2 meters per second, he sees an angry customer running after him. In order to avoid this conflict, what impulse does Roger need in order to change his velocity to 7.6 meters per second 9 degrees north of east? So impulse means the change in momentum, and the change in momentum is equal to the final momentum minus the initial momentum. So since there's momentum in 2 dimensions, we can't just simply subtract these two together. What we need to do is to draw a vector addition diagram, or in this case, a vector subtraction diagram, because we are finding the difference between these two. So we can start off by drawing the PF vector, which is going to look something like this. So it's 9 degrees north of east. And then we're going to add over the PI vector. So note that this is going to be a vector subtraction diagram. So when we draw the PI vector, we want to draw the opposite. So essentially what we're doing is adding the opposite of the vector that we're subtracting. So in this case, PI is going north, so we're going to be drawing it going south, which is the opposite. And the resultant is going to be the change in momentum, which is the impulse. So it would look something like this. So this is a right angle triangle, so it's going to be quite easy to solve for this vector over here, since we do know what PI is and we do know what PF is. So there's a couple ways that we could do it. Of course, is by using Pythagoras, getting this side and this side, squaring them and taking the root of that to find the change in P, or we could also just use trig, whereas we know this side and we know this angle, and we also know this side and we know this angle to solve for P. So let's just go ahead and do that one. So if we use PI and change in P, what we can write is this relationship. So according to this angle over here, this is the opposite side, and this one is the adjacent side. So what you could do is write tan of theta is equal to PI all over change in P. And if you want to just isolate for P, you can move that over. So that will be change in P is equal to PI all over tan theta. And PI is equal to the total mass times the initial velocity over tan theta. So now we just have to go ahead and plug in the values. So note that this mass corresponds to the total mass. So this includes Roger, his newspapers, and his bike. So we can calculate the total mass over here. So it's going to be M is going to be equal to 73, which is Roger, plus the newspapers, which is 6.3 kilograms, plus his bike, which is 13.2 kilograms. And that gives you a total of 92.5 kilograms. All right, so now we have all the values. We have M, V, and we have theta. So let's just go ahead and plug that in. So what we get is 92.5 kilograms times VI, which is 1.2 meters per second, all over tan of 9 degrees. And up here, this just becomes 111 kilogram meters per second all over tan 9, and that gives me 708 kilogram meters per second as the change in momentum, which is the impulse. And for direction, it's just going east. All right, so that's how you do this question. If you have any questions or comments, please leave them below. Thank you.